Wrap up most of this is a big section. Wrap up most of what this section is about. I want to try to, now that we've had a chance to look at this stuff for a little bit, I want to try to put this. I want to try to help you internalize a process for doing all this stuff that makes it easy, right? So here's kind of the way we'll do this. So we've been transforming parent functions by assigning values to parameters, right? And so what I want you to do is I want you to start off always. You're going to start off with the most generic way of representing g of x in terms of the parameters. We've got 3 of them. We're going to add one more today, and we'll get there shortly. And then you're just going to ask yourself, okay, which of these apply to the situation we're currently using, and discard the others. Determine what the value of that parameter has to be, and then just plug it in. Okay, that's a lot of talk. We'll look at that process with some examples that I think will make it easier to deal with. All right. So right away here, though, let's look at the stuff. This represents right here. This represents everything we've talked about so far. Right. There's 3 parameters we've talked about: A, H, and K, and they have very specific meanings. Right. Those are just numbers we're going to plug in, and they're going to do things to a function. They're going to tweak or transform the function in specific ways. So what does K do? What do you think? What does K do? Moves it up or down, right? So K translates the function up or down, okay? It's always going to be that way too. All year long when we talk about vertical translations, and we'll do it a lot all year, it's always going to be represented by K, right? The parameter K. H will always represent what? What's H do? Slides horizontally. Okay, so H is the amount that we're sliding or translating the function horizontally, and A will always do this. What we've talked about. What does A do? Stretches or compresses vertically, right? That's what these things will always do. Okay? All right, so let's look at a couple examples real quick of, not that. Let's look at a couple examples of the kinds of problems you've been working with. So how about this one? Okay. Oops. Okay, what about this one? So if we want to, there's our parent function, f of x, right? We want to transform that by translating it 3 units to the left. So first of all, which of these graphs represents that? So we're starting with that guy at the top. Which one is translated 3 units left? C. Everybody agrees it's C, right?
Yes, sir.
Okay, so now the question though is, how are we going to write that in terms of the function g of x? We want to write g of x in terms of our original f of x, right? So which thing are we doing? If we're going to go left by 3. Which of those 3 parameters does that involve? H. It does not involve A. We're not doing any vertical stretching. We're not doing any vertical translation. So get rid of those. You're always going to start with something like this, and we'll add one more parameter soon, but you're always going to start with the basic complete template and then just whittle that down to the one that you need. So the first step is going to be, we're going to rewrite this only using an H. Get rid of the A and the K. Okay, now all we have to do is identify the value of H based on what we're trying to do. So if we're moving it to the left by 3, what value of H does that correspond to? Caitlin, what do you think? If I'm going left by 3, what H value does that represent? H is just the amount of a horizontal shift, right? So it's negative 3, perfect, okay? It's negative, how come? It's going backwards. The positive direction is to the right always, correct? So we're going in the negative direction by 3. So this tells us right here, 3 units to the left, that's telling us right there that H equals negative 3. All we've got to do is take that value and plug it in. That's it. So what's our answer? Well, f of x minus negative 3. Okay, but that's not a very convenient way to write that. When I subtract a negative, what does it become? It becomes like adding. Good. So we'll rewrite that as f of x plus 3. Make sense? What are our steps? You start here. You eliminate the unnecessary parameters. You find the value of the parameter that you're working with and just plug and chug. Just put it in the equation, and that's it, right? So then if we go back to the problem, all I've got to do, and you've seen a bunch of these already, so this shouldn't be too new. All I've got to do is enter f of, inside parentheses, x plus 3. Whoops. Okay, we got it. Make sense? Okay, let's try that process again. I know these aren't hard, but let's just make sure we're working through the whole process. How about one like this? What if we want to translate the graph 4 units up? Okay, so which of these is translating at 4 units up? A is, okay, piece of cake. A translates at 4 units up. But, more importantly, what are we starting with? So let's start off here. I'm not just going to give you the template this time without looking at your notes. Probably should have your notes out, but it's without looking at your notes. What is our starting place? What's the whole template? G of x equals, good, A times, whoops, times f of
x minus h
minus h,
plus k.
good, plus k. So we're trying to go up by 4. So how would you describe that? That's a what kind of a translation or transformation? Vertical, what's the word?
Is it stretch?
Vertical, no, not a stretch. It's a vertical translation. If you want to call it a slide, that's fine, but it's a vertical, it's not a stretch, it's a shift or a slide or a translation, right? So which one of our parameters deals with that? K does. So we can just get rid of the other ones. We don't need them, right? So the next step, Jasmine, is what? How am I going to rewrite my template? G of x equals, you just told me, all we need is K, right?
X
Plus,
4.
okay, plus K, and then we're going to, you're right, so you did 2 steps in 1. Then we're going to identify what does this mean. Translating the graph 4 units up, well, that's telling us that K equals positive 4, so that's the value we plug in. So it's just f of x plus 4, right? Got it? Okay, no big deal. What if I wanted to slide it down? What would that mean? Yeah, K would be negative. If I wanted to slide it to the right, that would mean, what parameter would I be using?
Oh, divide. No, wait.
Hang on, if we're going to the right, sliding to the right, it'd be h, and it would just be positive, right? Okay, good, good, good. Okay, last one let's look at before we look at something new. Oh, I think it's that, whoops. It's this guy. Yeah, okay, how about this? Okay, this time we want to stretch the graph vertically by a factor of 3. Okay, so now remember, stretching the graph is different than translating, right? Translations mean we're going to take this function as it is, right, Abel? We're going to take this as it is and we're just going to slide it intact. A stretch is different. A stretch is going to change the shape. A stretch is going to distort it vertically, right? So if I'm translating, or excuse me, if I'm stretching it vertically by a factor of 3, let's look at this picture in detail for a second. Think about some reference points on the graph and how they're going to be changed. If I'm stretching everything vertically by a factor of 3, is that going to change the location of that point?
No.
It's not, because it's already on the x-axis. It's stuck to the x-axis. Only things that are above or below are going to get stretched away from it, right? You see how it's different than a translation. If this had been a translation, that point would have moved up, right? So that point's going to stay put. That point's going to stay put, right? What about, is there another point on here we probably ought to consider that might be a convenient one? Yeah, right here. The point at x equals 0, y equals 5. If I'm stretching this vertically by a factor of 3, what does the word factor mean in math, by the way? Factors are numbers or things that are what? Multiplied, right? Factor goes with multiplication. If I'm stretching this vertically by a factor of 3, where should that point end up if it starts with a y value of 5? 15, right? I'm going to multiply it by 3. So it's going to end up like way up there. So I should get something, whoops, that looks kind of like, well, it's bad. You get the idea, right? Okay. There's one other thing we can make another connection that I think helps with this. Translations always amount to adding or subtracting numbers, but stretches involve multiplying by numbers, right? Okay. So we could agree then on which one this is, I bet. Now you got to pay attention though. Some of these questions are tricky because the scales change. So we already said that top point should end up at 0, 15, but look at our choices. Our choices aren't so obvious. Well, maybe they are in this case. Okay, they started at, yeah. So which one is it?
B.
It's B. Okay, so that one is pretty obvious. I'll grant you that. Okay, but what are we going to do to this one now? So what's the, maybe we can skip the first step. What's the parameter associated with a vertical stretch? It's A, right? So we don't need to worry about H and K. We can leave those out. So we can start then with our template is just going to be f of x equals A times f of x. I don't need the H and the K. We aren't doing any translating this time, right? That's supposed to be a G. Sorry. Let's fix this. So my new function g of x is going to be a times my parent function f of x, right? So what's the value of a going to be based on what we're trying to do? 3. Okay, so this tells us right here, that is saying a equals 3. So what's our answer going to be? G of x equals what? What is it going to be? 3 times f of x, right? That's it. Okay. All right, what if I wanted to, real quick review, let's look at a vertical compression. Okay, what's this going to look like here? If I want to compress, here's f of x. I want to compress it vertically by a factor of 1/2. Well, factor tells us this is a stretch or compression, right? We're going to be multiplying by whatever the parameter is. So what's the graph going to look like? Let's take a good convenient point here. I'm going to pick one. How about this point right here? Or how about this point? This one was the point if we went over by 4, we went up by 4. The y value is 4. But if I'm going to compress it by a factor of 1/2, what should its y value be afterwards? 2, right? So it's going to be there, and we can see then that maybe our function's just going to look like that instead, right? No big deal, okay? What's the parameter we're using here? What's it going to be? A, H, or K? It's going to be A, so we can leave out the H and the K just like before. And what's the value of the parameter A that corresponds to doing that? 1/2. This is no big deal, is it? So that's the value we're plugging in. G of x equals 1/2 f of x. All right, so that's everything we've talked about. There's our review. What about a situation like this, though? What if we want to stretch the graph horizontally by a factor of 2? We haven't talked about that. All we've talked about are horizontal and vertical translations and vertical stretches. We haven't yet looked at horizontal stretches. So how do we deal with that? Yeah, it's going to be a little more complicated. So we already know that A represents a vertical stretch or compression, H represents horizontal shift, K represents vertical shift. But we're going to have to introduce a new parameter for horizontal stretches, and it's B. Okay, so B represents a horizontal stretch or compression. There's something kind of tricky about B though. Look where it sits in our template. It's on the bottom of a fraction. And look where the fraction goes. This makes sense. Think about this now. F of x represents the y value of a function, right? So where is A, which is the stretch or compression? It's being multiplied by f. It's getting multiplied by the y value. Makes sense. If I want to stretch something out vertically, I'm just going to double all of the y values, right? So I'm going to multiply whatever f, f of whatever, the function. F of x is just a fancy name for y, right? So I'm going to multiply the function's value, or the y value, by 2. But if I want to stretch something horizontally, I'm not multiplying the y values by something, I'm multiplying the x values, right? So it makes sense that the parameter b appears in front of the x minus h stuff, right? Okay. What's tricky about it, though, is that it goes on the bottom, okay? But if you just follow our plan, it makes it no harder, right? We're just going to start with the template, rewrite it in terms of the parameter that we're using, and then plug in the number that goes with what we're trying to do, and that's it. Okay, so then what about this problem we were just looking at? If I want to stretch the graph horizontally by a factor of 2, what am I going to do? Okay. So you got to memorize. It's not very often that I tell people to memorize stuff. Memorizing stuff is a kind of weak form of learning, so just forget it. But we'll use this enough that you won't. You got to memorize this, because this is where you're always going to start. If we can start there, if you can remember that, the rest of it's pretty easy. If you can remember this, and you can remember what those things mean, right? Okay, so what are we doing here? If we're horizontally stretching by a factor of 2, which of those parameters are we using? We're using B, right? And that you just have to know, okay? Right, so because you're not going to be given that. You'll have to remember that. For now, I'll give it to you to start with. So we're going to be using B. We can get rid of the rest. So the first thing we do is we're going to rewrite this then, right, as f of 1 over B. But if there's no h, because we're not horizontally translating it, do I need to put the x in parentheses?
No.
I don't, because isn't that the same thing as that?
Yes.
Right? So look, I can just write it like that. Okay? Without the a and the h and the k, that's all we need, is just the b, right? Okay, so let's look at what we're doing here. We're trying to stretch the graph of f of x horizontally by a factor of 2. So what's the value of b? 2, right? So what do I do with the 2? Plug it in right there, right? Okay, and I'm done. What's that going to look like when after I do that? Then? I get f of what? Not 2, f of 1 over 2, right? See that? That's my answer, f of 1 over 2, 1/2 x. Okay, make sense? It's weird that your answer ends up being 1/2. I know what you're probably thinking. Well, that seems like that would be a compression because there's a 1/2 in front of the x. But what you just have to remember is that the b is on the bottom. And so that's where I plug in b. So a b value of 2 actually ends up looking like a 1/2 in front of the x. Okay? So what then if I were going to do a compression? if I were gonna do a compression like, no. Yep, right there. If I wanted to compress this V right here horizontally by a factor of 1/3, first of all, what's that gonna look like? Let's take a reference point like right here, for example. This is the point we get when we go over 3 and up 3 on f of x. If I'm gonna compress this horizontally by a factor of 1/3, what's gonna change? It's still gonna go up 3, but now the horizontal part's gonna be only 1/3 as big. So it's only gonna go over 1, right? And it's only gonna go over 1 that way, and so it's gonna look like that, right? Okay, got it. Which of the parameters is affected by that? No, it's gonna be B, right? Because it's a horizontal stretch, or in this case, compression, right? K represents a vertical slide, H represents a horizontal slide. This is none of that stuff. This is actually kind of distorting the whole thing, right? Okay, so let's go through our little process. I know this is a little repetitive, but if you can just get this process down, you're going to have an easy time on this test that's coming up. Okay, so all we got to do then, okay, you will have memorized this, right? You will have memorized what those things mean, and you'll know then, because this is a horizontal compression, it's B. The rest of the stuff we don't care about, right? So once again, we rewrite this. Step 1, rewrite g of x in terms of B only. Step 2, determine what the value of B needs to be, right? Not very hard. Compress horizontally by a factor of 1/3. What's that telling us? B equals 1/3, right? Step 3, plug it in. That's it. Plug that value in for B. And so we get f of 1 over 1/3 x. Okay, that's the answer, but that's not simplified. What do we do when we divide by a fraction?
We put it upside down.
Remember, this goes back a long ways. If I divide by a fraction, what do I always do instead? Flip it and multiply. Good. So we multiply by the reciprocal. So instead of dividing by 1/3, we're going to multiply by 3. So our answer is then, this is just all equal to equals f of 3x, right? That's what we put in. Okay, no big deal. That's the answer. Okay, why is it a 3? Don't worry about it. It's a 3. I know it looks like it's going to be a stretch, but it's not, because remember, the B is on the bottom. It's going to be the reciprocal of what you think it should be. Okay? All right, so last issue. This is the new stuff for today. Very simple. Very simple. Let's say we want to instead, one last thing we can do. Nope. Yep. Okay, reflect. Let's do that one. Okay, what if we want to reflect a graph? This is the last thing we're going to do. We know how to do everything except reflecting. Reflecting is the easiest though. We got translations. What's that?
Didn't you say the divide?
For which one? For reflecting?
You said, yeah, so, no,
We haven't talked about this yet. We haven't talked about reflecting, but you can tell me in a second what you think we're going to do. So we know how to translate side to side, up and down. We know how to stretch, compress vertically, stretch, compress horizontally. Last issue is reflecting. So if we want to reflect a graph across the x-axis, all right, Jasmine has an idea. I think she has an idea. So let's say here, okay, Jeff,
Yeah,
we start off, this is f of x, right?
Yeah.
We've got a point here that has a y value of 4.
Yeah.
When x is 4, y is 4. If we're going to reflect this over the x-axis, so this is the line of reflection, right? There's the x-axis. If I reflect this thing over the x-axis, where's that point going to go?
-4.
-4, so it's going to end up right there, isn't it? Okay?
Yeah.
Everybody agree if I draw that with wet ink and I fold over the green line, it's going to make that imprint, right? Okay, now here's my question to you. How do we get, and here's another point, that we start there and end there maybe, right?
Yeah.
What would we do to these y values to make them end up down there?
Would you divide it? You don't put a -90.
Okay,
Multiply it, divide it,
I'm not going to divide it.
add it, subtract it.
No.
Add 2.
It's one of those, I agree. But what am I, if it starts off with a value of +4 and we want the value to be -4, what do I multiply by?
-1.
-1, right?
See, I said divide.
Right. That's close. The answer is multiply. That's close. All right.
Oh, wait, what? Oh my God.
So all we got to do if we want to reflect something. You're right. So if we reflect something over the x-axis, all we're doing is we're just changing the y value to its opposite, right? That's it. Okay. What if we had done instead? What if our function had been this instead? Yeah.
Can I go follow quick?
Yes, you may.
Thank you. Yeah, I do.
Okay. What if we had done something like this instead? What if we had had this function to start with? Okay, everybody focus. I know this is a lot of stuff, but just focus. We gotta get this done. If this is my starting function and I want to reflect this over the x-axis, what's the reflection going to look like? Let's draw it in red. Where is this loop going to end up being? Okay, below, and this one ends up being above, right? Everybody see?
Yes.
Okay, so what have we done? All we've done is we've taken the y values of the blue function and we've made them opposites by multiplying them by negative. That's it. So if this was to start with, if this value was, let's say that y value was -10, then this value right here is going to be +10. It's opposite, right? So what do you think then if we go back to our, yeah, to there, no, hang on, to there. Scoot that down. Which of these parameters should I make negative, do you think, to multiply everything by -1? No, not B. A. Yeah, it's A, right? Now think about this again. A is the number that's responsible for a vertical stretch, so it's also got to be the number that's responsible for a vertical reflection, right? All we have to do is make A negative to reflect over the x-axis, right? So then if we go to, there we go. If A is negative, we get a vertical reflection over the x-axis, okay? So what about this situation here? If we, well, that's not the one we want. Where was the one we wanted? Didn't I have one up here already? Thought I did. There we go. Didn't I have one?
No.
I could swear I did. Oh, right there. I just never copied it. There it is. Oh. All right, here we go. Okay, so if I want to reflect this across the x-axis, that's an issue with A, isn't it? Right? Not an issue with A, or excuse me, with H or K or B. So all I've got to do is take my original template, eliminate all the others. Now, what's the value of A that's going to reflect it? I'm not stretching it, so A is equal to 1 to start with, right? But if I want to reflect it, what did we say we had to do?
Multiply.
Yeah, we got to make A negative, right? So all we're going to do to this is just put a negative sign in front of the function. That's it. That reflects it, right? So to reflect it, we're just going to make A equal -1, right? That reflects it over the x-axis. And so all we have to do is we get rid of this other stuff. Is we're going to plug that value in for A. When I multiply by -1, though, do I write the whole -1? No, I just write the negative sign, right? So that just gives us negative f of x, and that's our answer, right? Okay. So then what do you suppose if we want to do a horizontal reflection over the y-axis? A was the variable or the parameter responsible for vertical stretches and compressions, and so it was also the one we had to make negative to reflect vertically. Which one of these parameters?
B.
Yeah, B, right? B is the parameter associated with horizontal stretches or compressions, so that's a factor, something we multiply by. And so that's what I'm going to have to make negative to do reflections the other way, around the y-axis, so horizontal reflections, okay? So if we go back then to here, and let's look at, I think it's this guy, yeah. We want to reflect this graph across the y-axis, okay? So first of all, what's that going to look like if I do that? So what's going to happen to this lobe right here if I reflect it across the y-axis? So it's going to end up being, good, it's going to end up being right here. And where's this one going to go?
The other side.
So the red one is the reflection, right?
Yes.
Okay, what do we do? Well, we just exchange the x values, right? So all we really have to do is just multiply the x values by -1. That's it, right? Let's go back. So if we want to take this template, last example, and then we can do it all. So if we're going to do a horizontal reflection, that's going to be letting B equal 1. The rest of them go away. But I want to show you something important here that's going to make this a lot easier. Okay? So we can rewrite this with only a B. Okay, we're going to let B equal -1, because that's what does this, right? That's making B negative, and we haven't, it's just 1. We haven't actually done any tweaking. We haven't stretched or compressed, so it equals 1. Look what happens when we try to plug that in. It looks weird. It doesn't look, it looks like it's not simplified. I get 1 over -1 times x. Well, what's 1 over -1? It's just -1, right? What if, let's just say this had been more complicated. Let's say that we had stretched this thing horizontally, so B was equal to -2. Let's say we had done two things. We had stretched it horizontally and reflected it. Even if we had done that, and B had been -2, that still would have looked kind of weird. We still would have gotten 1 over -2. Well, you don't put a negative sign on the bottom. Where do you put it? On the top or out front, right? You'd never put it on the bottom. So all you have to do then is when you want to reflect something horizontally, you can just take this whole 1 over B and just put a negative sign in front of the whole thing, right? You get it? Okay. So then, this would have ended up being just negative x, or in this case, if we had done a horizontal stretch and a reflection, it would have looked like f of negative 1/2 x. Okay, make sense?
Yep.
Okay, if you can do that process, which is not hard, you can do this stuff. Seriously, not a big deal. All right, we got a few minutes. I want to show you one thing that you guys need to be taking advantage of. Okay, on the assignments here, I want to make sure you know what all these things are. I got to share a piece of data with you, an important one. This is the first legitimately college prep math class you've taken. Okay, I want to have a talk with you soon about how important it is that you go to college, or you at least get some post-high school training. It makes, and I'll give you all the statistics, I've done a lot of research on this, you can find it too, but it makes a tremendous difference in what your life earning potential is, which is a big deal. Okay, I mean, I don't remember the statistics exactly, I gotta dig them up, but I've got this thing put away somewhere. If you are, for example, if you have a graduate degree, your lifetime earning potential is like, we're talking millions of dollars greater than it is if you don't have even a college degree. It's a huge, huge deal. It's literally the difference between having a good life and having a really hard life. And I want you to have good lives, right? And so getting through this process, this is one step in a chain of kind of academic classes, really English, and your English classes and your math classes and your science classes, Jasmine, are really the ones that are going to prepare you to move on and get through, navigate that next level, and put yourself in a position where you're going to make enough money to live in a nice house, be able to retire, have, health care for your kids, et cetera, et cetera, et cetera. All the things you're going to want to do. Okay, so this is the first class. The biggest predictor of success at that next important level for you is the ability to read a textbook, sadly. I think that's pretty tragic that that's it. But that tells you a lot about the way that you're going to be taught in college. A lot of what you do in college is going to be completely on you. It's not going to be probably the way it's been in high school or middle school. Okay. So you have to get to a point where you can kind of begin to independently learn some of this material, right? The good news is that in college, you're more than 90% likely to have all your classes, your analytic classes, your math classes taught online. So you're going to have some online resources like you have here. But you got to start using these things. I can see when people use these resources. In my Honors Algebra 2 class, there has been a huge usage of this stuff and my YouTube videos. There has not been a very big usage so far in Algebra 2. The only difference between Honors Algebra 2 and Algebra 2, in my mind, is that. It's not intelligence. Intelligence is it's a real cop-out. Because people, they always say, I'm just not. Yeah, you are. There's very, very little difference. If you look at the statistics, there is almost imperceptible difference in the actual raw intelligence of people in an honors class compared to a non-honors class. That's not it at all. The difference is this. The difference is work. That's it. 99% of the progress you're going to make or the battles you're going to win in life are not going to be based on your intrinsic abilities. That's a sham. It's all based on how hard you're willing to work. Promise you. That's it. If you want to work hard, you are 100% likely to be very successful. Promise you. So take advantage. You got to start to build these habits. What are these things? I mean, if you push this example thing, you've probably done it. It loads up an example that you can look at the exact kind of problem you're doing. You can go through step by step where it's going to walk you through each step and you can practice those, right? If you go to this, it pops up, it's on my other screen, but it pops up the textbook that deals with that issue, right? Okay, everybody should be looking up here, please. Right? If I go to this little link, it pops up the high energy guy. It's pretty high energy. He's going to give you a little, in this case, a 6-minute lecture that covers all this stuff. 6 minutes is not long, right?
Okay, well, here,
Okay, so there it is. If you go to the YouTube videos, those are updated every day. That's the stuff that we're covering in class, right? I want you to take advantage of the fact that I'm here to answer questions, right? I mean, we're going to take a lot of time in the lab and work on that stuff. You need to come into class ready to kind of just go a little hard. I didn't think today was great. I thought that some people were pretty into this, but I thought some people maybe weren't probably trying to spend this time as wisely as they could, right? That's your job. I will give you Monday's a work day, next Thursday's a work day. I'll probably give you another work day next week. But in order for you to be ready to utilize those things and get questions answered, you've got to start dealing with this stuff. This class is harder than it used to be. This is probably the equivalent of Math 95. Math 95 is the last class before they're actually worth college credit. So after this class, you should be able to start to earn college credit on every math class you take. But that means that it's not what Algebra 2 used to be. Algebra 2 used to be what Algebra 1 is starting to be this year. So you're kind of in transition. But you got to do some real math to get through this. There is no reason for you not to be successful. I will do anything required to help you get there. I'll be here before school. I'll be here after school. You know, I will be in the lab. I'll answer questions. But you just have to be to a point where you can start to utilize some of these resources and get the assignments done. I looked at the assignments, and there are a lot of people in this period who don't have more than the first assignment finished yet. Okay, that's a problem, right? It's not too late at all. We're just starting. But if that's you, you got to change things a little bit, okay? Does that make sense? All right. You good? Okay. Have a good weekend. Finish some things up. Utilize these things. Jeff. See ya. Listen, I want you to do a little. You can hit this stuff. Seriously. I don't want to. Just give me a second.
That's fine.
I'm not bad at all. That's not it. All right. Pushing for you.
Oh, they're like,
Are they pushing hard? Okay, good. That's huge. You've got some amazing opportunities. Because you're ethnicity, because you're a female. If you, you've got nothing but people want to throw in. Seriously.
actually, I'd be a first generation.
Awesome. So there's even that opens up. I'm not kidding you. That even opens up if you're a first generation student going to college. There's a bunch of other grant money that's available. We have a great resource. Are you teaching?
Yeah.
So we got a great resource here to get you through that. Through the what's it called?
Fire.
Yeah, it's awesome. A lot of schools don't have that.
Yeah.
But that's available to you.
Yeah.
You got to start thinking about that. And I don't want you. I don't have any problem with you going on this. That's awesome. You've got to find somebody that's going to work for you. But I want you to also start to kind of maybe try to learn to talk to me about this stuff too.
Okay.
Okay. And it's you can get this stuff, but you just have to be able to start doing a little bit more of this internally. It's not going to be given to
At
you.
my work, I actually we're getting internet there, so then I can be able to watch this stuff.
Okay. Oh, where is this at?
Hermiston.
Oh, good.
Yeah, I'm actually leaving there right now, so I can.
Oh, that's okay. Perfect. If there's ever an issue with that,
Yeah.
I can just tell me. We'll find a way for it to work here too.
Okay.
All right.
All right. Thank
Does
you.
that make sense? You bet.
Yeah.
Yeah.
Are we good for doing this right now?
Yes, we are. You bet. Would you? Okay. Here's what you got to do. Run over to Mrs. Jones. You know where that is?
No.
Okay, it's through that wall. I think it's I don't know. If you go around the corner, you know where Haywood is?
Yes.
Okay, next one past him.
Okay.
It's Mrs. Jones. Tell her I sent you. We got to borrow her. I just need the USB cable. I don't need the charger, but I'm going to update your phone and then you'll run it right back to her. Tell her you'll bring it right back to her in about 5 minutes.
Okay.
Okay, sound good?
Yeah.
All right.